I think it's very important as a founder to think what you're really best at, right? And there are some people who are, I don't know, let's say, born salesmen. They're very, very kind of quick to monetize any hype out there, right? They would be on it the next day. And if you think about, Nikolai and frankly me, we are not that kind of people. Hey, you know what? Being a hype expert is not us, right? But we can build you a generally good observability product, right? And that is what we're going to do.
This is DevOps Paradox, episode number 335. Stop building dashboards and start getting answers with Coroot. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, I'm going to give you a handful of names all together, and then I want you to tell me, after I give you the names, what comes to your mind first. Are you ready?
Go for it.
Datadog, Dynatrace.
Open telemetry.
No, hang on a second. Datadog, Dynatrace, New Relic, and Grafana. What are those
Open
four
telemetry.
things? Okay, OpenTelemetry, that's one of the things. Give me something else.
Observability.
Okay, keep going.
Me being poor.
That's a good one. Yes, that's a good one. Meaning?
Excluding Grafana. So kind of, if you exclude
Okay, fair
Grafana
enough.
from that list, then it's me going bankrupt. Yes.
Okay, but what's the one other thing that's common between all four of those?
I don't know. I know you're leading me towards some answer, but I don't know what that answer is, man.
They're all cloud-based. All
Grafana?
cloud-based. Grafana, you have an option. I will give you that. But the other three, the first three for sure,
Yeah.
are all
Yeah,
cloud-based. So on today's show, we have Peter Zaitsev on from Coroot. Peter, did I get your name right? Even close?
Yes.
Okay, good. He's a co-founder at Coroot. Coroot has a solution that is in that same family. Peter, correct me if I'm wrong.
You're right. You're right.
However, unlike the first three, we'll still leave Grafana out of it. We can run it locally, right?
Right. And also you wouldn't go bankrupt.
Well, okay. So it's possible you could go bankrupt. So let's pause it there for a second because, again, we like poking at the big three. But my question is, couldn't we still go bankrupt buying petabytes of disk and the power that it costs to run them?
Of course. In this regard, yes. But that's much harder to do that if you are actually just paying on the infrastructure costs, especially if those infrastructures run efficiently compared to having to pay those many times markup, which the cloud vendors especially have on the infrastructure costs to keep their margins.
So, okay, I went down a question I was going to use later to now. So let's pull it forward. Victor, you want to say something? Go ahead.
Yeah, I could now turn back your question back to you. Kind of, I could also come up with the word rich, rich, rich. And then when we jump into Peter, then call poor.
Okay.
Not turning as much as those are.
Okay, fair enough. We'll let him answer that later. But so Coroot has, can we call it an open core model? You have an open source community version, then you also have the enterprise or paid versions, and blah blah blah. We'll get to the
core
paid
model
versions later.
is exactly what it is.
Okay, I'm assuming let's talk about Coroot itself, but then I want to talk a little bit about the business as well, because in this time of, I can spend a week. Used to we would joke around. It's like, oh, we'll go to a hackathon and build something this weekend. In today's world, you can almost actually do that. Why did Coroot even come into existence with Okay, let's compare it to Grafana, right? Because that's everybody else we have to sort of set off the block. Why was it important for Coroot to be able to run self-hosted?
Well, I think a lot of that comes from differentiation. As you mentioned, there are a lot of cloud products in observability space, right? So that space is actually extremely crowded, and it's hard to get into that space. Where if you look at the observability for self-hosted solution, that is a different market. It's not so crowded, and I think that is also the space where the open source solution has much more benefits. I would say so. At some point, we may also offer the cloud-based version of Coroot for deployment for those people who are looking for simplicity. But at this point, we decided to only provide, as you mentioned, the open source version, our community edition, which is we are trying to be sort of like the best of breed when it comes to open source observability solutions, right? And then the enterprise version, which has some additional bells and whistles, which we hope enterprises would choose to pay for.
So let me back out a little bit. Can you compare yourself to the open source version of Grafana? Like, I think Grafana, I think only dashboards.
Oh, yes, yeah. I mean,
right. That's all I think about.
So first, I would say what Grafana and Coroot are not direct competitors. We have a number of people who would use Coroot, and then they would use Grafana additionally to get the data from Coroot and visualize, right? Get more custom visualization and so on and so forth, right? Some advanced people do it, right? If you think about the Coroot, right, and if you think about Grafana, and actually what got excited me years ago when it just came to market is how fantastic, sort of like a Lego block it is, right? It really allows you to build your own visualization. Hey, you can get a data from about anywhere and visualize it in so many different ways. And we've plugged in even more different ways. But that also is exactly that Lego experience. You can build almost anything with Grafana, but you need to build it. Now, if you look at this case, Coroot is a solution not for somebody who wants to spend their days building an observability system, but it is focused about a developer who has an application to run. And in the modern world, right, you can't really have a successful application operations if you don't have observability. Things are just very complicated. You think about the microservices, you think about talking to external APIs and so on and so forth, right? So if you want to get that observability, but you want to get that easy, that is where Coroot comes in. Coroot is also what you can think about the opinionated observability. We are not just saying, hey, we are going to show you whatever you want to do, right? We are saying, hey, if you want to operate your system effectively, if you want to resolve problems quickly, you need to look at those things. This is a methodology you follow, and this will give you results simple and quickly as possible. For certain people, it is awesome. For some observability experts, we can say, oh my gosh, I don't want you to tell me how to look at my data and how to use it. Well, in this case, they can either build their own systems, all together, right? Or complement Coroot with something like Grafana.
I think Grafana did itself misfavor that they named the company based on the first product that they worked on, right? Mm. In reality, Grafana is realistically Grafana, Prometheus, and whatever they call the tracing solution and so on and so forth, right? Lucky.
That's right. But that is even more building blocks. Right, you have a visualization building blocks, you have a visualization block for time series, you have a visualization block for tracing, and so on and so forth, right? And then you go and put that together, and you can do absolutely awesome things with it.
Yeah, so this is kind of like if I understood correctly, the difference is that Coroot is the out-of-the-box solution in a way, while Grafana family, let's say, would be, hey, you install those 5 things and you need to spend a few hours looking for existing dashboards that you want to use and then potentially go and modify them to fit your needs, right? This is kind of out of the box, right? Open the box and you have observability. Is that more or less the direction?
Yes, that's right. But I think it's also important, like a philosophical difference, right? Because if you look at a lot of companies in the observability space, and not just Grafana, they have this philosophy as more is more. If you get, more metrics, more logs, more tracing, right, and we give you more dashboards, hey, you know what? Like 1,000 of dashboard is better than 10. And yes, for certain kind of user, it is absolutely the case. In our case, we think what the less is more. We think about, hey, how to help people to avoid that cognitive overload, right, if you will. How to give you the minimum essentials to achieve your goals. And it's not only about visualization. If you think about important part of Coroot, right, and another problem we see in observability is observability rollout. You mentioned, for example, OpenTelemetry. Fantastic technology, but that is also not an easy to roll out. If you really want to roll it out, you have to configure your applications to emit OpenTelemetry traces. For some new applications, that's maybe easy. If you have some old applications, we don't have a team maintaining them, or some proprietary applications, that would be invisible. In Coroot, we are using eBPF, so you can that is technology which allows us to get visibility for any applications without any additional instrumentation.
So how does that work? Do you kind of run an agent, let's say, in my Kubernetes cluster that automatically instruments every container, pod, what's or not, over there?
Yes, that is
Something
exactly
like that, right?
So you would have an agent which will instrument every container, every pod, right? It will understand how different microservices talk to each other, and so how errors and latency propagate. If you are running that in VM environment or bare metal, kind of the same thing applies, right? We need to get an agent over node. But this agent, I think what is important, it doesn't require configuration, right? It's really instruments things automatically, right? And there's a lot of like a sophisticated things like say, oh, we are looking, for example, what something which looks like a log file is open, then we'll automatically detect that, and then we'll start analyzing that as a log file. You don't need to, because of that, understand what kind of applications you have and wherever you have a log files and where those log files go, if that's files, right? And so on and so forth, right? So we are trying to get as many of those kind of nice little tricks as possible to really reduce the things what users need to do to get their observability.
But then if I have, let's say, application that I instrumented because I need traces that are not generic, but I want to trace this specific function in this specific moment in time, whatever, right? Do you still kind of like, is the less is more mandatory, or if I already have traces, you pick it up still, right?
Yeah. Oh, yes. Coroot can consume OpenTelemetry traces as well, right? So if you, because you can get more if you spend the time instrumenting application. If you have that information, Coroot is able to consume it. Again, like also if you spend time, for example, to give Coroot credentials from a databases, right? It will able to get more data, which it can get directly from database like MySQL or Postgres, right? If you don't, it still can get a lot of information about errors, about performance, right? Based on the traffic of how your application sends queries to the database and gets responses back.
So it's almost kind of to observability what Docker was for, or is to orchestration in a way, right? Kind of, the major difference between Docker and Kubernetes would be that Docker and Docker Swarm in the past would be, hey, this is out of the box, kind of 5 seconds and 5 minutes and you're up and running, or you have other extreme Kubernetes kind of, you get amazing results, but you need to roll up your sleeves type of solution, right?
That's right. Right. So our focus in this case is to make sure you get the easiest solution out of a box. The other thing what we didn't talk about, right, is what a lot of people are looking for, right? Because we often talk about logs, traces, metrics, right, and have it kind of visualized in the dashboard. But what we think in Coroot is really the outcome people want to achieve, right? And that is often, hey, I have a problem. I want to fix that as easy, as quickly as possible. And that is where with Coroot, we do a lot of root cause analysis, where we are able to highlight what exactly went wrong. And I think that is the most important also concept here, what we are saying, hey, if something goes wrong, we're not expecting you to go through the dashboard, right? We are expecting you to tell you what exactly went wrong, and then also use their AI, LLMs, right, to give you possible fixes. And we can do some pretty good stuff in this case, which probably can give you useful advice to cover 80% or more without a lot of human analysis.
Now you brought up AI there. We've already talked about being able to self-host everything. Can we self-host the AI as well? Or am I going to be stuck? I mean, I can, but am I going to get the results that I would get from, wait a week and you get the next big model. And I don't think the self-hosted models are there yet.
Well, and I think that is an important challenge in this case, right? So we are giving a lot of flexibility to the users in this regard, right? First, of course, you don't have to use AI functionality, right? If you are saying, hey, there is no freaking way I'm sending any of my data to AI, right? Well, okay, cool, you can do that, right? Then you can use locally hosted models, or you can use some of external models. Number of people we can see, if it's a large enterprise, they may host some of those models on Amazon Bedrock, for example, which can give you kind of a good results, but that also can be easier operate compared to just rolling out your own stuff on GPUs directly.
I want to go back to eBPF real quick. We've talked about eBPF on the show before. Could Coroot have existed without eBPF?
Well, not in this form, because I think that eBPF is awesome technology in terms of what it's being powerful, but it is also very safe, right, in terms of how it's engineered, right? Because if you look at what Coroot was doing in the past, let's say before eBPF was in existence, you could say, hey, we are going to run like a special kernel model, which is going to have functionality which is kind of somewhat similar, right? Allows us to intersect everything. But that is a very scary proposition, right? Not a lot of people say, hey, we want to inject some kernel level stuff in our production boxes. That's kind of sounds very dangerous, right? And also considering how many different Linux versions out there and flavors out there, it's also is very hard to maintain and keep safe. That is why you can see a lot of companies which would do some sort of kernel level work, not only in terms of observability, but also, for example, security or network filtering. We are saying, hey, you know what? Instead of us running kernel models, we are trying to implement as much stuff on eBPF as possible because it's very high performance, but that also is very safe compared to alternatives.
So do you just produce the eBPF files? I can't remember what they are. It's been so long since we talked about them. Do you just produce them? And so when I do the install of the quote unquote agent, I'm assuming there's some sort of agent. Is that correct?
Yes,
okay.
There is an agent.
So when the agent installs, then it drops in the eBPF files where they need to be and life goes on?
Yeah, not exactly. So let's kind of drill a little bit into how things work. First, we talk about eBPF, but eBPF is not the only technology which Coroot uses, right? It uses a lot of a standard technology as well, and it's kind of connects that together with what eBPF is, right? Like, for example, if we can intersect the traffic going on right between two connections, but then we can use what is exposed through Linux procfs or wherever to really understand what process it is, right? To maybe to what container that belongs, and so on and so forth, right? So you have a lot of information sources out there which are kind of being glued together, but eBPF is a core of it. Okay, now let's look at what is eBPF and how that operates. The functionality we use in eBPF is specifically able to hook up to any function calls inside the kernel or inside application. Right. So, for example, we can hook up to where the connection is initiated and to say, oh, that is connected to that host, and it took, so much time. Right. In this case, stuff like that. Now, eBPF as a technology, it actually consists of two parts. There is a kernel level part and there is a user level part. So in a kernel level, that is a very small function which generates events or counts some sort of stats, which are stored in that kind of fixed memory in the kernel. So there is no kind of files, because files are slow, right? And files can potentially block things if you are trying to write to the storage, and storage is slow, right? And so on and so forth. It's all very fast on the memory. And then there is an agent which asynchronously can consume that data. So, for example, a kernel has a ring buffer, right? And then the client would consume events from this, the client in this case being an agent, consume this data from a ring buffer, and then sends that to the Coroot server. So that's how that pretty much operates.
So we have our data flowing from our nodes, we'll call them that, because they could be a physical server, they could be a pod, whatever it is. I mean, a pod's on a physical server, but go with me here for a minute. We have all that data flowing into the Coroot server, and I'm assuming that's where the magic pixie dust is applied. And then I can choose to use Grafana if I want to for visualizations, or I'm also assuming there's some basic visualization. I don't mean to disparage it, but basic compared to what Grafana can do from a dashboard. Am I going over too far?
I would say it's not just basic, but it is different. Right, because if you look in Grafana's approach, right, there is a lot of that is based on a fixed dashboard. If I want to have a graph which looks in kind of in particular way, it works pretty well. In the case of Coroot, there is a lot of those dynamic visualization. One of the core things, for example, we can visualize map is about how different services are talking to each other, how traffic between them flows in real time, and so on and so forth, right? And that is a pretty unique visualization, which would not be easy to repeat in Grafana, especially without plugin. But now, if you look in this case and say, well, I want to plot some specific disk utilization metrics, right? Or, how different host group CPU usage looks like, right? Kind of sum group together, right? Average some way. Where Coroot has some custom dashboarding functionality, it's not nearly as advanced as Grafana. And that is, I think, where it is awesome. And then you mentioned this kind of a special magic, right? The important thing what Coroot does is it really is very good at linking things together. How things propagate, where errors originate, and where those errors can impact the upstream services.
That's where we were talking about root cause analysis.
That's right. That's right. Root cause analysis obviously is using that, but you are also able to visualize that in a different way. To say, okay, I am seeing what this service is having in errors. Let's look at that. Its latency increased to that database, right? To that given microservice, which is slow because the database is being slow. You can look at that manually, right, through visualization tools, right? You can do the root cause analysis, which is going to do that for you.
So back to the visualizations real quick, and we'll definitely move on from that. Pick the right tool for the data you want to look at, is what I'm hearing.
Yes.
It's if I want to see the time series of CPU utilization or disk in aggregate over servers, Grafana might be the better way to do that. Or if I already have dashboards already liking Grafana, great. I can bring those over-ish.
That's right. And I think this is something which is also important, and how observability tools are different from some other things, right? If you are using database, for example, you typically have to make a choice, right? Oh, am I going to use Oracle? Is it going to be Postgres? Is it going to be MySQL? Is it going to be Mongo? It's not practical to use all of them together. When it comes to observability, it's typically you can use multiple tools. Especially if you think about, there are some observability tools which are sort of, good visualization. There are some fantastic observability tools which are done for, interactive diagnostics, right? Maybe command line, right? And so on and so forth. And you can think many organizations, if you look at them, they would be using multiple observability tools for the different purposes, right? So it's not either or situation.
If we think back in the times before OpenTelemetry was really adopted by what we were calling the big three earlier, it was that way. You pretty much picked a tool, or every silo within an organization picked a tool and did their own thing. But once OpenTelemetry came into play, that helped break things down a little bit. And then once eBPF was inserted into everything and people started using it, that also broke down more walls. What's the next big wall that needs to be broken down?
Well, I think you're right in terms of kind of certain walls, right? But I think it all goes into the level how deep you are actually going to go, right? Because I have a lot of connection to the database world. And in a database world, there is a lot of stuff which doesn't quite maps neatly on things like, traces or metrics and so on and so on and so forth. For example, if you look at the queries, right, you don't want to trace every single queries because there may be, like a millions of them in seconds, but you want to somehow cluster queries together, right, so we can analyze how they perform. They're based by, for example, execution plan, right, or some other things, right? There is some rather complicated things how you want to analyze deadlocks, right, for example, which is kind of really all this kind of fancy graph theory under it, right, which has its own visualization tools for that, right? So that space has a lot of additional special tools I would highlight, right? Or another tool in which I mentioned, right, which is, yes, based on OpenTelemetry, but you think about BPF trace, right, for kind of standalone analysis, right, or something like inspector gadget, which is focused on, hey, let's see what we can get from a system now, what is going on, right, where the OpenTelemetry, right, or metrics captured from eBPF are typically something which you keep historically, right? And I want to say what those things are fundamentally different because of why, right? Because if you think about, oh, I'm going to store something for a long time, right? And I don't want to go bankrupt, right? By either paying those guys for, gigabytes of logs or metrics or trace I store with them, right? Or even myself buying petabytes of storage, right? I have to limit that some way. There is also some limitations because even with eBPF, instrumenting everything costs a lot of, CPU. At the same time, if I'm interactively diagnosing something, I kind of like enable debug mode for everything, right? Or at least the things I care, and really have some very, very specific data to analyze that while the problem is ongoing. And this is why I would say just saying, oh, you know what, I have an OpenTelemetry and I feed that to the Datadog, so I don't need any other tools, right? I don't think that is quite correct.
I got hooked on when you said store everything forever or something in that direction. How do you deal with retention? So I assume that when you said at the very beginning, less is more, that the definition of less differs greatly depending on the period of time. Like less for last week in my head is very different than less for a year ago.
Yes. Yeah. I mean, if you look at Coroot, at this point, we have ability to disable some data sources, right, which you don't want. We also have ability to use sampling for data, as well as some other kind of specific data reduction techniques, right? And then you can limit the period for which you store. We do not do at this point the data shrinkage in a way like, oh, we'll go from 1 second interval to 5 seconds or like to 5 minutes or something like that. That is kind of hasn't been really the feature of a product we worked with, right? So typically we would limit that to say, you store the data for a month in Coroot, right? And that is what is focused on, right? Again, that's more of a diagnostic tool, right? We don't really design it saying, hey, I want to really graph solution like what's going on for 5 years, right, and to really see how trends have been operating. That's haven't been a problem.
Because, until not long ago, I was very much in favor of, I don't understand why would you store data longer than a week, a month, or something like that. Kind of, who cares really about your CPU memory performance networking from a year ago? Kind of, come on. But now I can imagine how that would be useful in some different format with AI, right? Because there is an obvious usage of AI. Hey, help me fix this issue, right? And then it digests the data, comes up with solution. You say it looks okay, do it, and so on and so forth, right? But I feel that we are entering into the age of when AI could be predicting things. Like scaling could be a good example, kind of, hey, for 5 years, you had outage around Christmas, because of this and that. This is what we expect based on these trends and stuff like that. So I can easily imagine it serving double purpose on a very different timescales in a way.
Oh yes, I mean I am totally agree with you, right? But I think this is also an important thing, right? I think if you are a relatively early stage startup with a small team, then it's also very important what you focus on, right? There is unlimited amount of things what you can do, right? But you just have to choose what you're going to focus on. And this kind of a long-term trending just was not focus for Coroot at this point. I'm not saying it won't be.
So let's talk about that small, you're referencing yourself with that small startup, but let me flip it around. Let's say you've got a small startup that's wanting to use Coroot. They don't mind self-hosting. That's easy for them. What is the minimum stack for them to get a functional Coroot? Not just a hello world, but something that I could throw 1 or 2 apps at and it not even blink.
Oh, I mean, if you're talking about like resource usage.
Resource usage, yes.
Yeah. I mean, I would say we did not try to have a Coroot to be, like a super small resource usage. But I would say if you have a server with 4 gigabytes of memory, right, for that server, that can operate, quite fine for maybe 10 nodes with a decent amount of pods.
So that seems reasonable. You say 4 gig, and 4 gig all of a sudden feels really small nowadays because it is. But it could still work, is what I'm hearing.
Yeah. I mean, I'm even installed on the smaller amounts, but I mean, I would rather sort of under promise and over deliver, right? In this case, man.
Yeah. I want to go back to the top of the show where we were talking about the open core model around Coroot. Why did y'all choose to do that? Does it just feel like it was something that needed to be there and y'all could do it?
Well, what I think in this case, look, like let's go back maybe to the Coroot genesis. Coroot was really started first by Nikolai Sivko. Before that, he built and sold the SaaS observability product. Right, in this case, which did kind of a lot of like a similar things to what Grafana is doing, but kind of like a simpler, hey, we're going to capture a lot of data, provide a lot of visualization, and so on and so forth, right? He wanted to get this another take, right, as saying, hey, we want to really focus on providing answers, simplifying things, and so on and so forth, right? But also you can think about the observability market was very mature at this point. All right, like it's I just went KubeCon and you would see like took a picture. There's probably like 100 of observability companies, right? And each time I come to this show, right, there's like a 50 more. It's a rather crowded market, and in this case, from a business standpoint, I think that is where open source, right, has ability to attract people to give a second look. The ability to disrupt things, right? Especially, I think, if you are looking at the open core business model, and if it's not really crippleware, if your open source version is actually quite powerful, that can be very helpful. I think it also changes, in this case, how much capital that requires to get in the market, because if you think about the open source, I think there's much more, people are much more open talking to each other about tools kind of and helping the projects, right, which they've been given. So I think that's an answer. And if you're asking about, but why didn't you do it as a pure play open source? Well, there is also the need to build a sustainable business out of it. We did not want to go some way as, some other companies doing, hey, we guys are open source forever, and then, oops, we can't make any money doing that, so we're going to change a license, and now everything is not open source. Then we found what for observability space in particular, that is a way which allows us to build their sustainable business and also give back to open source community. They're both me and Nikolai own a lot to their open source community.
Well, I think it's interesting that you brought up the bait and switch. Most of the time when you see people that bring something in open core and they make a big deal about it being open source, it's always AGPL or BSL or some other license, whereas you all went with Apache licensing, Apache 2.0 to be specific.
Mm-hmm.
Did you pause at that, or were you just like, look, in your background, you come from database, and I believe you were at Percona, correct?
Yeah. Well, I mean, I am the founder of Percona, yes, and I'm still involved with Percona company, yeah.
But again, it was based on Percona. Come on, Darren, you can think about this. This is MySQL, right?
Yeah.
Was it based around? So again, let's not talk about Oracle and Oracle things, but you feel much more comfortable staying in what I call the true open source licenses. Yes, AGPL's open source, but it's got a lot of, I can't build a business around it. Whereas you took the exact opposite. I could build a business around using Coroot Community Edition.
Oh, yeah, absolutely. And I'll tell you more, right? There is quite a few companies out there which use Coroot agent. And then, same as I can say, hey, guys, you can get the data with Grafana. They utilize their own GUI, right? Some are in the cloud. Some are also like self-hosted solutions. And that is fine with us. We also get some good testing from them, good contributions back, sometimes in our agent, right? So we decided what that is the balance which is going to work in this regard. Now, I think if you, our philosophy in this case is this, right? We really want to maximize the adoption. So, hey, we don't want to have like any restrictions about how Coroot open source can be adopted. Hey guys, you want to adopt part of it, you want to build in Coroot in your, let's say, some commercial offering you ship to the customers, you can all do that. Now, we believe in this case, if that unrestricted adoption, also we have more adoption. And then, you know what? Some companies are going to grow up in their complexity, their maybe compliance issues, right? So we'll want to get our Coroot Enterprise Edition. So that is a long-term game for us. And I think there is also like being a relatively small startup with a small team, right? We don't have a high burn rate as some other companies are. That gives us luxury of patience, right? Which I think a lot of this, high octane venture funded companies, they just, don't have. They kind of have to really deliver a lot now, right? And that is where I think a lot of those bait and switch license changes come from, right? Because, well, they kind of still grow in revenue, whatever, but it's just not the exponential growth, right? Which was baked in when they took some venture capital on very high valuation.
I did not do my math as well as I should or done my research. Has Coroot taken VC?
Coroot has taken some angel funding. But again, that is like that's
very different.
very, very minimal as well.
Okay, that's good. So that explains a lot because you're not feeling the pressures to AI all the things. I mean, you feel pressure to get AI into things, but you're not being forced into, okay, why isn't 90% of this AI right now?
Well, that's right. And I think that is a very, very important. I think that is what is also important for us as founders is to take the really good decisions which have technical merits, right, and not just be carried away with, I would say, like a flavor of a day, right? Because always we have been like a hype cycles kind of coming in, right? I think this is here's also something which is important, right? I think it's very important as a founder to think what you're really best at, right? And there are some people who are, I don't know, let's say, born salesmen. They're very, very kind of quick to monetize any hype out there, right? They would be on it the next day. And if you think about, Nikolai and frankly me, we are not that kind of people. Hey, you know what? Being a hype expert is not us, right? But we can build you a generally good observability product, right? And that is what we're going to do.
In building that, again, talking about the AI part of it, I mean, yes, you could have written all the things to do the RCA, root cause analysis work. Has AI really helped you in that? In getting to answers better, quicker?
Well, yeah.
Not?
So here is, I think, is interesting, right? Because if you look at AI, I think especially over the last few years, AI start to mean LLM. Hey, let's us just go and dump everything kind of, to ChatGPT and friends, and it will just figure things out, just from that. But when we think about that, right, there is a lot of things which actually benefit from like a systematic analysis. If you think about Coroot, the core things of that is what we can actually build their map of your system. We can see how errors propagate. That is not probabilistic. That is not something which, different LLMs may have a different opinions about, right? You can actually have a form that's kind of very systematically certain kind of analysis with mathematical precision, and that is what Coroot does. Let's say, hey, your problem originates here. And I think that is kind of, you can think about like a stage one. Now, the second thing is about, let's say, oh, that's cool, right? Let's say my latency is stored on, my database is stored on Amazon EBS of, certain type, and my latency is high. Now, what can I do about that? Okay, cool. That is where we can really provide all that kind of context and ask ChatGPT or other LLMs for help. That is very, very good, having that all the information which they have to come up with a good context, right? But it's not really so much of a diagnostic where a problem is, but really kind of those kind of more specific things like, okay, why exactly the latency could be high, right, on EBS volume, and what you can do about that, if that makes any sense.
Oh, it makes a lot of sense because EBS volumes are spawned from the pits of hell because they can be really, really bad. So if I was debating on starting with Coroot today, what is my steps? What do I need to do? We already talked about, I need a 4 gig machine. Okay, we'll probably need a little bit more than that, but I don't need to go out and old school days thinking Grafana Prometheus. I don't need to go come up with a 5-node cluster for Elasticsearch. I don't need to come up with XYZ, all these other things. What does it really look like?
Okay. Now the moment you mentioned Elasticsearch, you made it easy. Because nothing can be more demanding than that.
Well, look, so I would say there's like a couple of ways like you can do it, which is an easy one is if you have Docker, for example, you can get the Docker Compose, right? It will install the Coroot application itself as well as some dependencies such as ClickHouse. The easiest way there, I think, is to get started is to deploy Coroot on Kubernetes, if you have that. Because if you deploy that, we have a Helm chart, you get it deployed. It not just deploys where Coroot, the application itself, but it's also kind of gets all your nodes instrumented, right? So you can say, oh, boom, right? I have that visibility in 5 minutes. But I would say if you want to explore, you don't even have to start with deploying Coroot, right? You can. We have a demo out there which can give you a very good feel, right? It's have deployed their sort of like a standard open telemetry demo. They have this kind of application with some failures being periodically injected out there, and you can see what Coroot provides and to see if that's interesting.
I want to go back to the Helm chart you just mentioned. Mm-hmm. We're now in January, which means we're at T-minus 60-ish days before Ingress Nginx dies. from support at least. Is Ingress and Nginx in your Helm chart at this point?
You got me there. As I understand, it's not. But believe me, if it was, right, it won't be by that time.
Okay, I'm just checking, and maybe not just checking. But it's like, oh, I hadn't thought about that. We should check that. How do you feel about that? You said you were at KubeCon this past year. What was your takeaway from that when you heard that? It's like, is this the first domino to fall?
Well, in my opinion, in this case, that is always this kind of a challenge, right? In the open source and in terms of like an ecosystem, saying, hey, you know what? Okay, what do we have resources or do we want to maintain, right? And on and at what conditions? I frankly did not dig into that much. What I know in general, kind of if you participate in sort of both in database and Kubernetes ecosystem, it's kind of interesting how different philosophies can go, right? Kubernetes, especially in its early days, was always kind of very, very quick. Introduce something doesn't work out, depreciate that, kind of move on and keep moving, keep churning. In database, we're often a very, very conservative. You implemented something, you cannot depreciate that. And even if nobody uses that, then that's probably going to be like a 10-year depreciation cycle, because database is kind of a very slow-moving thing in general.
I would agree, except that I wouldn't say use the database word over there. I think that what you're describing can be applied to maturity or the age, right? Something similar is happening in a way in Linux kernel, right? Because it's been around for a while, everybody's using it, we don't mess up with it in the same way as we were messing up with Linux kernel's first 10 years, right? Or even with Kubernetes. Everybody's much more cautious with Kubernetes now. I'm talking about Kubernetes project itself, simply because, hey, it's been 10 years. We are not in year 2 anymore, where we can just introduce random ingress and see what happens, right?
Yes, look, I totally understand, right? That I think that happens with maturity, right? But I think it's also like if you look at every particular point in time, you can see different communities. They do have a different sort of, let's say, attitude to risk, attitude to saying, hey, we can innovate and then we can, decommission things. Like even if you the database world, like I say that, and yes, like if you look at, MySQL, Postgres, that's kind of very conservative. But I remember when MongoDB came out, right? It was decades after those databases. It was like, we are kind of moving very, very quickly, right? We can break things, remove things, add things. It's can change things, right? It's fine. That's how we roll, right? And that was very fine for the developer community, right? Maybe which was like, whoa, kind of shockingly strange for MySQL or Postgres guys.
So we talked about how you could get started. You could do it with Docker Compose. You could run it inside Kubernetes if you already have a cluster. You could just try it out on the demo site. Mm-hmm. But let's say I, go down the path and I go ahead and self-host it. Like I'm liking it. Why would I want to switch from self-hosting to the hosted version?
Well, first, we don't actually have a hosted version, right? So the choice what you have is, hey, do you want to run the enterprise version, or do you want to stay with community? That is probably your question.
Okay, that is the question then. So why would I need to switch to enterprise?
So if you look at the enterprise version, there are a couple of different reasons. One is the features differentiating. So, right, some of those AI analysis, they are built in the enterprise version. We actually have some AI analysis in the community version where it's done kind of slightly different. It sends the data to Coroot Cloud if you want to enable that with analysis performed there, right, rather than on your local host as it exists in enterprise version, right? But mostly I would say the heavy-duty root cause analysis is the enterprise feature, right? And the second piece, which comes from things like permission, role-based access, right? That is also in their enterprise version, something which your larger teams needs, right? So if you are deploying that in scale, you have a different teams which need to have a different visibility in Coroot, right? That's what enterprise version provides. But I think Another very important part of open source, right? When you're deploying any software and that becomes mission critical, you often want to be thinking about support. Like, hey, if it breaks, who's going to be fixing that, right? Or if there's any security issues in that software, and so on and so forth, right? A lot of larger enterprises, they prefer to have a vendor relationship, or often that is even required in their internal compliance documents.
Compliance documents. Enterprises cannot exist without legal departments. So therefore, we have legal and security. So Coroot can be found at coroot.com. That's COROOT.com. And all of Peter's contact information will be down in the episode description. Peter, thanks for being with us today.
Okay, thank you. I appreciate it.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.